Welcome to Systems Analysis and Design, and today we're going to talk about use case diagrams, which is a piece of object-oriented analysis. And so we have our key terms, and you've seen this slide before. There's, 10, 12 different terms that are key terms in the unified modeling language. And you can see the ones highlighted in green are the ones we're going to look at. These are in alphabetical order. And we have class diagram up at the top, second down. Unified modeling language, which is what we're using, and then we have use cases. And today we're going to focus on use cases, so the last of these key terms. And then we've also seen this, all the different UML diagrams chart. Last time we visited together on object-oriented analysis, I showed you this chart. And again, this shows everything that can be done, split into two halves. On the left-hand side for you have structural diagrams. On the right-hand side, we have behavioral diagrams. And you can see that on the structural diagram side, we have object and class diagrams. And those are what we're going to do after we've looked at behavioral diagram use case diagrams. We're going to look at use case diagrams today, and that's a type, a subclass of the behavioral diagrams. And so just as a kind of recollection to go back over something we've already done, structural diagrams tell us what's there. It gives us the building blocks of your system. And obviously those are going to be very important, and we are going to do them. We're going to look at behavioral diagrams, use cases today, and those show how the system responds to requests. And typically, as you're going to see, we're going to have an actor working with the system, and these use case diagrams will lay out all the different ways the actor and the system can interact with each other or be used. And that's what a use case means. This is a case of how we will use the system. This is something we've covered before, but let's make sure we understand it. So a use case is a complete sequence of related actions initiated by an actor. And an actor, or actor, as I might say, is an external entity that interacts with the system. Now, we draw actors as stick figures, and that makes them look like a person, but they don't have to be a person. Typically they are, and I think it's probably the best way to understand things right from the start. But it could be another system that interacts with our system. That's, in complex, large organizations, that's nearly always going to be the case. But at the end of the day, we have actors, usually people, sometimes other systems, that interact with our system, the one that we're looking at, the one that we're analyzing, the one that we're designing. And a use case lays out a complete sequence of related actions. So now let's go ahead and take a look at an example. And here's the example, a use case of a client with a restaurant. And I am a big fan of understanding things using pictures. So here we have a picture. And you can see there are four actors here. There is, on the right-hand side, we have the chef, we have the waiter, we have the client, and the cashier. And so this is not a complex restaurant. And then you can see that we have a systems boundary. And that's really important because it shows what's going on inside our system. So we have a system boundary. All that is the, rectangle that shows us what's in scope and what's out of scope. And so we've got our system boundary there. So let's take a look. Let's start with clients. So that's the middle one on the left-hand side. That's the middle actor on the left-hand side, client. So a client comes in, and of course, you can imagine that the first thing they want to do, they sit down, but the first thing a client wants to do when they come to a restaurant is eat food. And so you can see that our top oval at the top says order food. The first thing that a client needs to do is order food. And so you can see that the top oval that we have at the top left of the diagram there says order food. Now again, there's going to be a lot of complexity behind the process of ordering food, and that's the beautiful thing about use case diagrams. It's the beautiful thing about object-oriented analysis. We can hide the complexity inside the oval. So we want to order food, and you can see that another actor, of course, is involved with the ordering of food. And so we have a waiter or waitress, and you can see that there's also a line that goes between the waiter and the ordering food, and it says receive order. Makes perfect sense. And that goes off to the left. Going off to the right of ordering food, you can see that maybe this is a restaurant and maybe this is a client who wants to order wine. And so we have that order wine as another oval, another thing that can get done, another action or activity that can happen inside our system. And again, when you order wine, there's lots of things that can happen. Waiter provides you the wine menu, gives you some suggestions. You look through the wine menu, you make some choices. Buy the glass, buy the carafe, buy the bottle. So there's a lot of choices that go with ordering wine. And those are all encapsulated inside this one oval. All right, so that's the order food. And that's the waiter has received the order. And as you can imagine, the next thing that happens is the waiter then places the order. And so we have a line going down at an angle, 45-degree angle to the, what is that, southeast, down to the oval of serve food. I think this is a little bit odd, actually, because if you think about it, I think the waiter actually should have a line first to the chef. And you can see in this particular picture, I think the waiter receives the order, and then there's a line that goes from order food down to the chef. I think that should actually come from the waiter. Not necessarily too incorrect, but you can see there's a line that goes from order food to chef, and it says confirm order. I really think that's really more of a kind of give order to chef line, and I think it should come from the waiter down to the chef. Anyhow, now over on the right-hand side with the chef, there's a oval that says cook the food. And again, a lot of complexity behind cooking the food, and it's all hidden there. But that's something, that's another activity that takes place inside our restaurant. So once the food is cooked, again, I think there would be a message. So there should be a line from cooked food going out to the waiter saying order is ready. So that's missing off this diagram. But nonetheless, we're back at the waiter, top left, and there's a line that says serve food. And again, that would be the next piece in the process. And you can see also that down to the kind of southeast, there's a serve wine. And again, that's just another activity that takes place with or at the same time or even before and afterwards with the serve food. And there it says if wine was ordered, which kind of makes sense. You only get to serve wine if it was ordered. And then, of course, once food's been served, what happens next? The client eats the food, and we indeed have that. So we're back to the client actor on the left-hand side in the middle there, and there's a line to an oval that says eat food. And then off to the right of that, there's also something that says drink wine, but only if you ordered wine. Once you finish the food, I think we're missing here the fact that the waiter would clean up the dishes. So I think that's missing off here. So this actually doesn't capture all the different activities that could take place, all the behaviors. And I think it should, but nonetheless, it's not too bad. Then the client needs to pay, and you can see this oval bottom left of our system's boundary is something that says pay for food. Also off to the right of it is pay for wine if we ordered wine. And that payment obviously goes out to the actor at the bottom left there that says accept payment to the cashier. So that's a pretty decent use case diagram for a client at a restaurant. So here we have just 4 bullets that kind of explain some of how to do use case modeling, how to think about it. One is that a use case is always initiated by an actor. Remember, that's someone, or it could be another system. It represents complete functionality of what needs to get done. And that's why I think that example actually, it was missing a couple of pieces of functionality, the waiter cleaning up the plates. So I didn't think that example actually did represent complete functionality and could have been better. Use cases can participate in other use cases, and use cases may also be used by other use cases. And that last bullet gets to the point that an actor could be a system. So let's walk through now the steps of use case modeling. So here we have step one, and step one is identifying your audience. So a use case is a particular purpose that a user can actually use the system to get things done. Very powerful way of presenting what the system is going to do for customers, users, management, and peers. And so this particular slide here has a lot of detail on it, but what it's trying to explain is you need to think about for whom and who uses. And those are two different people, two different sets of people. So you need to identify whom the system is for. That's your customer. Now, as the systems analyst, you are going to have someone that you're doing this work for. That is your customer. But your customer may or may not be the person who uses the system. And typically, actually, when you're doing these in organizations, your customer is actually quite different from the user. And that's because usually your customer is senior level management driving the project, paying for it, and the users are the worker bees getting the work done. And so they tend to be two different people. And you need to make sure you appreciate that there are two different sets of people that you need to be concerned about and who they are and how to think about them differently. And so this slide is doing that. Your customers are sometimes called clients. And to be honest, in my experience, they're always called clients. It just seems to be the way it is. And so you are going to be working with those clients. Typically, you have a contractual relationship with them. So you need to talk to your clients and make sure that, obviously, you need to get your client happy. An unhappy client means the system's going to fail and it's not going to get things done. Now, you of course need to talk to your users too, and those are the people who use the system, typically the workers, as it says here. They are going to have the best information about how things get done, what needs to get done with the new system, what was working before, what wasn't working. They're also typically the ones most ingrained in their habits. And sometimes you need to break users of their habits or free them up from the constraints of their habits. As it says down at the bottom here, UML has a special term for users, and they are called actors. So there you go. We talked about actors, and those are the people who are going to use the system. Okay, let's talk about actor pairs, and this is where the terminology gets just a little, I don't know, trickier at some level. As this slide says, many systems have paired sets of actors. So nearly there's always someone who uses the system and someone who receives the use of the system. So back to our restaurant example, we had the client coming in to eat the food, but then we also had people on the other side of that, the cook, the waiter, and the cashier, who were on the other side of that process. So nearly always in any system that you design, there's going to be actor pairs. The example they give here on this slide is in the hotel registration system. So there's going to be a potential guest, and then on the other side of that, that guest is coming for an event, so there'll be an event organizer. There's going to be a registration clerk. So there's nearly always people, of course, who take care of the other sides of those. So when a guest comes in, there's a registration clerk. The guest was coming in to do an event. On the other side of the event, there's the event consultant or the event coordinator. So nearly always things happen in pairs. Someone who wants something done and someone who gets the doing done. And so make sure when you're thinking about your system that you consider that there are actor pairs. And anytime you have one person wanting something done, think about who's going to get the doing done. Now, we've mentioned this before, and we draw actors as a stick figure, but as I said, not all actors are people, which is actually true in the real world if you think about it. Well, never mind, it's kind of like R2-D2 and things like that. But nonetheless, back on point here, there are non-human actors when it comes to systems. And so we need to consider that as part of our systems analysis and design process. And as this slide explains here, there are databases. Databases are classic actors in a systems analysis and design project. And as it says here, if a database is external, it is an actor. If it's external to your system and you're grabbing data from it, then that is going to be considered an actor. If the database is internal to the workings, then it is not an actor. So going back to our client going into a restaurant, no external databases for that, but if you can imagine the menu is an internal database of all the choices that you can make. That is not, the menu is not represented as an actor. It's just part of the system. It's contained in those ovals. So I think that's actually a good way of looking at it. As it says right at the bottom on this slide, as you think about this, the more that you are able to control and design something, the more likely then it's going to be internal and not an actor. So the menu is a great example of that. You know, the restaurant has complete control over the menu, what goes on, when, and how that's displayed. And so that doesn't become an actor in our systems analysis setup. Now, it might be, of course, when you're doing all this stuff, then you're going to have input devices. Cameras are a great example for bringing data in. And then there's also going to be output devices. So on the input side, you can have sensors as well. And so I do a lot of work with bees and beehives. And so when we're checking to figure out the healthiness of a beehive, we look at the weight, we look at the traffic, bees in and out, we look at the temperature inside the hive and outside the hive. Bees don't fly when it's too cold or too hot. And so those are input devices. As it says here, you know, a TV remote is a good example of an input device. And then there's also output devices. And output devices, almost by definition, they're going to change the way an actor interacts with the system. And so I think there's a good example at the bottom of this slide here. Consider the card reader in an ATM system. It reads the card to get identity and account data of the person who's trying to get cash out. As such, it acts for the person as a way of getting his or her data into the system. Therefore, it should be considered an actor. And that's the point here. It's input devices and output devices really should be considered potential actors. And the notion here is that the card reader in an ATM system, that is an actor because it's going to get a lot of things done for you. So consider it as an actor. The display in an ATM system is an actor for much the same reason, because it outputs data to the user. All right, so the whole unit is one device, and it's got a couple of actors into it. One is the card reader, one is the screen. So that's a great example of incorporating devices as actors in your system. So as you're trying to work out who and what are actors, one of the things you need to consider is the role that the actors play. And this slide kind of is trying to show you that you need to identify the roles of actors. As you look for actors in your system, consider that an actor, a person, may play different roles. And actors in use case diagram, we want just to specify them for the individual role. So person, David Firth, professor, I'm going to do teaching, research, and service. And those are three different actors for the one person, David Firth. And so we need to separate those out in our diagrams. We need to be a little careful. On this picture here is kind of trying to explain that. A hotel desk clerk does reservations and check-in. And so there's two actors there. One is reservation clerk and one is check-in clerk. And the reservation clerk takes care of reservations, and the check-in clerk takes care of room assignments. So one of the things you need to really consider is breaking down tasks right down to the role that a person does, not the person themselves. And that can take some effort to do. Then we need to think about how to name actors. And it's just like when we were naming classes and all the process we went through there. So you need a noun, usually singular, and as it says here, often formed from an active verb. And so Organizer, consultant, debtor, customer, professor, employer, registrar, all great names for actors. So typically it's, remember, a use case diagram is about getting things done, and that's why an active verb applied to the actor is the way to label them. So if you think about it going back, we had the reservation clerk, because the clerk is making a reservation. That's the thing they are doing. We have the check-in clerk. The person getting the check-in done was the task they were doing was check-in. So when you're giving an actor a name, make sure you think about the action that's taking place. Then, as it says here, when you're naming non-human actors, use the name of the role that the hardware or external system performs. So remember, if there's an external system to organize the potential guest credit cards, what it's doing is credit card authorization. So call the actor credit card authorizer. And again, this just takes a little bit of practice, but it gets down to the task that's being performed by the actor. We want to label that actor using the task that's being performed. So there's a process in UML called exposing actors. Isn't UML awesome? We have public parts, private parts, we expose actors. I think someone had a bit of a sense of humor when they were coming up with unified modeling language. And maybe it's partly why it became so successful, is people found it a little bit funny. Well, let's talk about exposing actors. And all this picture is doing is saying, hey, when the actor's a person, draw it as a stick figure, like this potential guest. And when the actor's a system, then draw it as a rectangle. So we know that it is a system and not a person. You can see the labeling here as well. That allows you to understand that you do know it's an actor, but you put it in a box because it's a system. So I recommend, if you have an actor that's a system, well, one, you have to use a box, but I would recommend labeling it as actor, so everyone's very clear about what's going on. Now, back to when we were teaching class diagrams, we talked about something called generalization and subclasses and superclasses, and we have the exact same thing with actors. And I think just this picture down at the bottom, generalizing actors, does a great job of explaining that. It might be when we were walking through the system, we had this notion that we had a potential guest. And the potential guest is, going to look for a hotel reservation, find out what the price is there availability, and then maybe book. And then it might be as we go on that we realize that there's some frequent travelers who are also going to come in. And they're different, potentially, from potential guests. But at the end of the day, they're probably going to perform the same tasks. So they are going to look for a hotel room, see what it costs, book it, and it's just the payment mechanism that changes. And so sometimes, as this picture shows, it's worth generalizing things to, rather than an actor called potential guest and an actor called frequent traveler, we can just call them reserver, which captures both, which generalizes them to both. So generalization still applies to actors. All right, we're getting really close to doing use cases now. And what we've got here is showing your system's use cases. And basically what this is saying is, hey, once you've figured out who your stakeholders are, that's your clients, who your users are, who the actors are based on the users, then you're really close to being able to use UML to draw a use case diagram. And each use case gets initiated by an actor, whether it's a human, a device, a clock, or some other input device. That leads us to defining use cases based on actors and goals. And so what you need to do to get this done is put yourself in the place of each actor. So you need to think about how an actor will use a system. Consider the goal that a human actor has when they use a system. Determine the job the actor performs while using the system. Think about the outcome the actor is looking for. So, for example, making a reservation returns a reservation to the actor. Checking in returns a room assignment and a key. Checking out returns an end of room assignment, typically a bill as well. Those are 3 different use cases initiated by the same actor, making a reservation, checking in, checking out. That's the same actor, but 3 different ways of interacting with the hotel and their hotel reservation system. So again, an actor who's, let's say, a traveler, needs to make a reservation, and then you get a reservation back from the system. Then you come and check in, you get a room and a key. So you've got the person doing it and the goal that was achieved. And then the last one is when you check out, it's the same person, they're checking out, they give the key back, and they receive a checkout notification and a bill. So you've got actor and you've got outcome. And that's a great way of defining your use cases, is to think about actors and the things that are getting done. And the biggest issue students have here is kind of trying to get too much done in a use case. So keep things simple. And it kind of says that at the bottom of the slide, actually. You need to have a primary actor, that kind of the one actor who participates in the use case to get things done. The main person is the one who's going to drive your use case. So think about the check-in again. You're going to have a person checking in. Well, there's always, remember our actor pairs, there's always going to be someone else on the other side of that. And indeed, you could think about the person checking in might have their husband or wife with them, right next to them, and they're going to need a key, and they're going to need a room, potentially the same room, but not always. Maybe it's your brother or sister. So make sure you always have a primary actor, and you drive from the primary actor and the goals. Okay, this is our first use case diagram example. And what it's showing here is use cases for a potential guest. And you'll see that there are 3. And the system that we're building here or analyzing is a hotel reservation system. And you can see right in the middle, we've got our we've got our vertical rectangle. And it says at the top, system, hotel reservation. Off to the left, we've got our actor. They are a potential guest. And this potential guest, again, there's 3 use cases here, 3 ways we are using the system. And those are shown by the 3 different ovals. And so first, this actor, this potential guest, wants to make a room reservation. And then as part of that, or even differently, we might want to just check room availability. Hey, can some other friends come? So we've got one use case is making a reservation, another use case is checking availability, and another use case is canceling the room reservation. So this picture, those 3 ovals show the guest on the left and 3 different use cases of how we might use the hotel reservation system. And again, the beauty of this high-level use case diagram is all the complexity is hidden inside that oval. And then off to the right, you can see that making a room reservation means that there's going to be a credit card authorization that needs to take place, and that's an actor. This is shown as a rectangle again with the word actor. Remember, this harks back to the fact that an actor can be a person or a system, but we need to label our system. We put it in a rectangle and we label it as actor. And as you can see, it's quite clear, making a room reservation, that's going to require a credit card authorization. Canceling a room reservation also hits your credit card, usually backs out the deposit that's been made, but just checking room availability doesn't need credit card authorization. Now, the last thing I want to point out here is when it comes to labeling things, you'll notice it says make room reservations inside the oval. And then it says check room availability is outside the oval and underneath it. And cancel room reservation is outside the oval and underneath it. UML really does require you to put the wording inside the oval for the use case. But there's plenty of tools that don't do that because that's actually quite difficult to pull off. If you change the size of the oval, it usually screws the words up if you've ever tried to do this in Word or PowerPoint. So a lot of times the tool will just put it underneath the oval. Since we're not going to use a tool and you're going to be doing this in pen and pencil, let's get UML right and let's put the label for the use case inside the oval. So let's talk about multiple actors. And what this slide does is actually a nice job of kind of describing the multiple actors. What it says here is nearly always there's someone who's in charge of the use case and someone who's kind of just along for the ride in the use case. And the example we just gave is a great example of how to handle this. The potential guest is the person driving everything here in these use cases, making a room reservation, checking room availability, and canceling room reservations. Those are all driven by the potential guest. And the way we show that is the direction of the arrow from the guest to the use case. Now, we need this actor called credit card authorization system to help us get this done, get these use cases done. And we show that by having the arrow from the use case to the actor. So the primary actor gets to have the arrow come from them, and the along for the ride actor gets to have the arrow go to them. And this picture shows that quite clearly. Talk about multiplicity. We actually talked about this in our classes and objects, and it's still the same again here. Almost nothing's changed. So let's just drill straight down into this picture here. And I think it's going to be fairly obvious, actually. You've got a potential guest, and one of the use cases is make a room reservation. Well, one guest can make 0 to 1 room reservations. And I would actually say that's possible, that you can make more than one. So actually 0 to star is probably more correct here. But I guess the way this system is set up is you can only make 1 room reservation. And to be fair, I have used systems like that. And then this leads to 0 to many credit card authorizations. Not entirely sure where we have more than 1 credit card authorization for a room reservation. So I think that would be 0 to 1. So I think this is backwards. I think this would be 0 to star from the potential guest for room reservations, and it would be 0 to 1 on the way out. But hey, checking room availability 0 to 1. That means we get to pick 1. You get to check room availability just for 1 room. That's probably true. And then canceling a room 0 to 1. That would also make sense why they make room reservations would be 0 to 1 as well. So there you go. Okay, let's talk about some rules of use casing. The first rule is how to name your use case. Well, a use case is a behavior. It's how you use something, so that's a behavior. So it needs to have a verb phrase. And if we think back, we had make room reservation, check room availability, and cancel room reservation. And so those were pretty good. That was a verb phrase. It had an action verb in there. So that's rule number 1. Choose a good name, make it an action verb phrase. Illustrate a complete behavior is the second rule. A use case, the whole point of a use case is that it's complete behavior, starting with the initiating event from our primary actor and usually getting us all the way to our goal. If you think back to the restaurant, we had the order food, we had the cook food, we had the pay bill, and so make sure that they take in an entire complete behavior. And so it's really easy for students to kind of get a little too granular on this. The whole point is you capture whole behaviors. So as this slide says here, specifying the bed size when you're ordering a room or booking a room between king, queen, and double, that's just part of making a room reservation. So you would hide that complexity within make a room reservation. So you wouldn't have a use case of specifying the bed size. That just wouldn't make any sense. Check room availability, though, as it says here. That is something separate because you don't need to make a reservation for that. So I think you would keep check room reservations separate as its own use case. Plus, remember, the outcome is just whether it's available, whereas the outcome for making a room reservation is going to be a credit card hit. So there was an extra step, an extra outcome, an extra actor involved in the making a room reservation. That wasn't the case in checking availability. And if you think about how you've done this online, then you know that's true as well. And so another rule here, and we've kind of touched on it, is identify a completable behavior. You've got to be able to get something done. And it says when you name the use case, choose a phrase that implies completion of the action that you're trying to do. So reserve a room is better than reserving a room, because reserving a room is kind of ongoing behavior. It's something you continue doing. I'm in the process of reserving a room. So you should label your use cases based on the outcome, the goal of the use case. Reserve a room. Provide inverse use cases is another rule, which is the reserve a room and then cancel a room. So that's why we had that on there. Back to our restaurant example, we didn't have order food, cancel order for food. That just is incredibly rare. And so I don't recall any inverse use cases on our restaurant example, but I think they're incredibly rare actually, and they're treated as special cases. But we all know that when you're making a room reservation, then canceling a room reservation is definitely a use case. So make sure that you need a use case that, as it says here, unaccomplishes a goal, does the opposite or just unwraps the goal that you did. So that's another rule. Another next to last rule here is limit the use case to one behavior. So check-in is separate from check-out. So make sure that you have your use cases limited to one behavior. And as it kind of says it here, check in and check out. Anytime you need the word and, then you need to split your use cases into two. And then finally, use case diagrams. The last thing you need to get done here is you need to make sure you represent the actor's point of view. So use the terminology of the actor, the person using the system, not the system example. All right, so make sure you use the user's terminology, not the system's terminology. So you would allow a guest to use the system to reserve a room, all right, and you wouldn't name that use case schedule room assignment, although that's what the system's going to do. You would name it reserve a room because that's what the actor wants to get done. And this actually gets really tricky, as you can imagine, because if you're working with a hotel, they see things from their perspective, not the user's perspective. So you need to make sure when you're thinking about these things, and certainly when you're a systems analyst and designer, it's really easy to get drawn into the people who are building the system and start thinking about and naming things from their perspective. No, name it from the actor's perspective, and then you'll get things straight. And that is all the pieces for our use case diagrams.